Alright, so today we're going to be talking about day 2 of lesson 7 of module 3. And we're going to be talking about still transversals. Today we're going to introduce the idea of what happens whenever there are parallel lines. Alright, so if we know that the lines are parallel, they will be indicated by the two little arrows that you see here on lines A and B. They have these little two arrows. They should be the same size and roughly in the same spot. But they will show us that our angles are parallel. Now, if parallel lines are cut by a transversal, then these four things are always true. All right, and they have to be parallel for these things to be true. If there's no little arrows showing they're parallel, these things are not necessarily true. All right, so the first is that corresponding angles are congruent. So all the corresponding angles are the same angle measure. The next, you have alternate exterior angles are congruent. And then you have alternate interior angles are congruent. And lastly, same side interior angles are not congruent. They are supplementary. Which means they add up to equal 180 degrees. All right, so we're going to find all of the missing angle measures here for example 1. All that we know so far is that this upper left side angle measure is 120. Well, first of all, I know that vertical angles are congruent, so I know that this angle here has to be 120. And then I also know that linear pairs form 180 degrees, so that means that this angle here is going to be 60 degrees. And then this vertical angle means that's going to be 60 degrees as well. All right, so now let's look at the other things I know. I know corresponding angles are congruent, so that means that upper left 120 and vertical 120 and upper right is 60 and bottom down here is 60. Now I proved that all of that by doing vertical angles and corresponding angles, but we could have used lots of measurements there. We could have, with that 120 that we knew, we could have done alternate exterior angles to get this one down here to be 120. We could have done alternate interior angles. Once we had this 120, we could have done that 120. And then we could have done the same thing with that 60. Lots of ways to prove all those angle measures there. All right, so now let's look at this. Example 2. If the measure of angle 3 is 4x plus 7, so angle 3, we're going to label it 4x plus 7 degrees. And the measure of angle 6 is 5x minus 13 degrees. All right, well, we just need to figure out the relationship that's going on. All right, so we need to figure out, I guess we're looking for x, find x. So we are going to, first of all, figure out the relationship. Well, they're on opposite sides of the transversal, so that means they're alternate. They're between lines J and K, so that means they're interior, so alternate interior. And alternate interior angles are congruent. So that means that 4x plus 7 is equal to 5x minus 13. All right, so now we can just subtract 4x from both sides. And we can add 13 to both sides. So I get 20 is equal to x. X is 20. All right. Moving on here. All right. So the first thing we're going to do here is look for x. I know that 4x plus 22 is equal to 5x because those are corresponding angles. Which I believe that means that x has to be 22. If I subtract 4x from both sides, I get 22 is equal to x. So x is 22. Now it's looking for the measure of angle DCE. Measure of angle DCE is going to be 5 times 22, which is 110. And the measure of ECF, this is a corresponding angle then to the one that we already had given to us, which is CBG, and so that would be 70 degrees. Now the angle relationship that we used to solve for x, we did corresponding angles. All right, example 4, we have 2x minus 135, and we have x. All right, well, this time, the relationship that we have is not corresponding. Those are going to be consecutive interior, or same side interior. And I know that consecutive interior angles are supplementary. It means they add up to equal 180. So 2x minus 135 plus x equals 180. So 2x plus x is 3x. So 3x minus 135 equals 180. I need to add 135 to both sides. So I get 180 plus 135, get 315. And so 3x equals 315, then just divide both sides by 3. And I get 105 is our x. Now the measure of angle DBC is that 2x minus 135. So that's going to be 2 times 105. And then we subtract 135. So that's 75 degrees. The measure of angle BDH is the x, which is 105 degrees. And the measure of angle ABF is going to be vertical to that 2x minus 135. And so that's also going to be 75 degrees. All right, last example here. Example 5. Find y if the measure of angle 8 is 68 degrees. So we're just going to go ahead and label that 68 degrees there. And the measure of angle 3 is 3y minus 2. So let's fill in some things that we know. We know that angle 5 has to be vertical to 68 because it's vertical to 8. So that's also 68. And I know that 3 and 5 are consecutive interiors, so that means they add up to 180. So 3y minus 2 plus 68 is equal to 180. So that's 3y plus 66 equals 180. So that means 3y, 180 minus 66, 114. Divide that by 3. Sorry, I should have shown that I subtracted 66 there. 114 divided by 3 leaves us with 38. Y is 38. And that's all we had to do is figure out y. I know that the rule of that means that 180 minus 68, that 3y minus 2 equals 112. I could have done that. It's just done 3y minus 2 equals 112, but we'd end up in the same spot. So this works just as well. So, all right, if you have any questions, shoot me a message on Canvas, and I'll get back to you as soon as I can. Have a great day.